All right, as we get started today, we are going to begin with some word problems. And today, pretty straightforward word problems where basically we're just going to have a single unknown or, really reliable unknowns with algebraic representation. So those who go back in your minds to Algebra 1, everything's pretty straightforward algebraic representation. You need to remember that sum means you add. If you have something like a product, you would multiply. Of means multiply, is means equals, things like that. So let's take a look at some problems here together. Really straightforward. We just need to translate that question into a sentence. And what would we write for what number increased by 14 gives 30? Well, anytime it says what number, it's what we don't know, class, we can simply call that x. And then it says increased by, that means add. And then it says 14, so of course we put 14. Then it says gives. Now I mentioned a moment ago is means equals, but in general verbs mean equal sign. Tie a little bit of English class in here. So when it says gives 30, class, we could simply say equals 30. And you probably solve this in your head. What is that number, class? 16. Now keep in mind, those of you who might not be familiar with Algebra 1 for me, so some of you knew, on a word problem, half the credit is this. The other half is that. So if all I see is 16, you only get half the credit. We need equations and answers. But again, this is very straightforward. How about this next one? How would I write the equation for what number multiplied by 3 is equal to 54? Brandon? What's the equation I would write for this second problem?
3x equals 54.
There we go. What number multiplied by 3? In other words, 3x equals 54. There's the equation. There's half the credit. And again, solve this in your head or on your calculator if your head's not that great. And what do we get for x, Abby? 18 is correct. Still pretty straightforward. Again, word problems like these where there's only the one unknown, that's pretty straightforward. How about this one, Michael? How would I write the equation for what number diminished by 45 is equal to negative 15?
X minus 45 is equal to negative 15.
There we go. And to solve here, class, I would need to do what to both sides? Or what would I need to move over, I guess we could say?
45. The
45 as a positive 45 to simply get x equals 30. Pretty easy, all right? There's some other types of word problems where it's going to be pretty consistent with your unknowns, where it's not one of those where you have to figure out how to represent what. It's going to be more of a memorized list. For instance, we should remember topics like consecutive numbers. Well, consecutive numbers like 13, 14, 15, 16. We said we could represent any number, class, as x. That's a good choice. Any letter you said there would have worked, but x is my favorite. How would we represent the next consecutive number? X plus 1. If you add 1 to any number, you get the next consecutive number. What about the next one after that? X plus 2. How about the next number after that? And then after that. And so on and so forth. And you realize you could literally keep going to infinity, right? Make sure you have this in your notes. It's a little, at least the beginning of the pattern in your notes as well. Consecutive numbers. Any number could be represented as x. The next consecutive number, of course, would be represented x plus 1, then x plus 2, x plus 3, and so on and so forth. It's logical, but it's a good thing to memorize, so that way you've got that in your brain ready to go. So, when it says find 3 consecutive numbers whose sum is 42, well, obviously, I only need a first number, a second number, and a third number. I don't need to go past x plus 2. If it says their sum is 42, how would I represent that statement, Maddie? There we go. If you added these together, you'd add up the x's to get 3x, you'd add up the constants to get 3. 3x plus 3 equals 42. And at your seats, do 2 steps to solve. And I did not intentionally pick those numbers that I started with. Just realized that. What is my first number, class? 13. So my numbers are, in fact, 13, 14, and 15. Those were not intentionally picked. I guess that was subconscious. But anyway, 13, 14, 15 are, in fact, the 3 consecutive numbers. here. How many remember working problems like these in Algebra 1? We may also come upon odd numbers or consecutive odd numbers. And let's refresh our memories from Algebra 1 here a little bit. What is it that makes an odd number odd? It's not even. That's exactly right. So what makes an even number even? Wrong. Being divisible by 2. In other words, if there's an even number of things, it can be evenly divided in half. I think that's where the term even comes from. It can be evenly divided in half. Or in other words, it's divisible by 2. So then, if I wanted to represent in your notes any even number, I would have to represent something that could be divided by a 2. How can I represent any even number then? If I just say x, how do I know x could be divided by 2? 2x. Make sure you have this in your notes. Any even number could be represented 2x. You're guaranteed even no matter what integer you put in for x if you multiply by 2, right? And then it will be an even number. Okay, so then, if I wanted to represent any odd number, or more specifically, I guess I should say any odd integer, I would need to come up with something that isn't even. Even is 2x. How would I represent odd then? Sorry? Well, but if x is like a 4, 3 times 4 would be 12, that's not even. And not all odd numbers are divisible by 3. But if you take any even number, I don't care what even number it is, 64 for instance, and add 1, you're guaranteed an odd number, right? Because odd numbers are always 1 more than the previous even. So write this in your notes that any odd number could be represented 2x plus 1. Make sure you have these statements in your notes. Any even number, 2x. Any odd number, even plus 1. You're guaranteed odd at that point. This particular problem, though, wants for consecutive odd numbers. Okay, so we've got first number, second number, third number, fourth number. We said that any odd number could be represented, class, 2x plus 1. What would be the next odd number? Well, if we counted odd numbers, let's start with 13 because it worked last time. 13, 15, 17, 19. What are we doing to go from one odd to the next? We're adding 2. So if I added 2 to 2x plus 1, what would I have? 2x plus 3. What about the next odd number? How about the next odd number? And you realize you could keep going for a while, but in this problem I specifically need 4 consecutive odd numbers. How many remember this from Algebra 1? All right, questions on this? All right, so when it says that the 4 consecutive numbers have a sum of 40, how would I set this up? How would I write this equation? Genesis? There we go, 8x plus 16 equals 40. And then, of course, to solve, do your 2 steps, move the 16 over, and then divide away the 8 from both sides. And we end up plus with x equals 3. Now, some students have fallen into the trap of saying, wait a second, 3, 5, 7, 9, that does not add up to 40. But remember, x isn't your first number. Your first number is 2x plus 1. So what is your first number, class? 7. Then the next number? And there are your consecutive odd numbers that add up to 40. Questions on this? Let's take a look at just one more word problem. Then we'll get back to what we've been working on recently. Find 2 consecutive even numbers whose sum is 26. Well, class, how do I represent any even number? 2x. Okay, so then we wanted, we only have 2 of them, first number and second number. So if my first number is 2x, again, if we were to count even numbers, 4, 6, 8, 10, 12, and so forth, we're doing what? Going from one number to the next. Adding 2, right? So if my first number is 2x, which is any even number, the next consecutive even number, class, would have to be 2x plus 2. Careful, not 4x, but 2x plus 2. What about the next even number? 2x plus 4, then after that, 2x plus 6, and so on. But I don't need to write those, right? I just write these two here, because I only need two consecutive even numbers, whose sum is 26. Kendall, what's our equation?
4x plus 2 equals 26.
And of course, we'll subtract away the 2, and we'll divide away the 4, and we'll end up getting what class for x? 6, but we'll end up getting what for my two numbers? 12 and 14 are my consecutive even numbers that add up to 26. Questions on how to represent these statements? Questions on consecutive numbers, consecutive even numbers, or consecutive odd numbers? All right, so quick review. If I want to represent any number, class, just call it x. If I want to represent any even number, class, call it any odd number. So if I wanted to represent consecutive odd numbers, we would have to start, of course, with 2x plus 1, then 2x plus 3, 2x plus 5, 2x plus 7, and so forth. If I wanted to represent just consecutive numbers, start with x, then x plus 1, x plus 2, x plus 3. If I want to represent consecutive even numbers, Michael, we better start with
2x.
2x. And the next consecutive number, class? 2x plus 2, 2x plus 4, 2x plus 6, and so on and so forth. Again, largely that's memorized, but also should be able to think through it intuitively as well. All right, homework handouts out. Homework handouts out. Solving rational equations. In other words, equations, class, with fractions. How do I feel about fractions in my equations class? Hate them. And so, because I hate them, I get rid of them. Right, get rid of the things you hate in your life, right? It's like, no, not Genesis. We love Genesis. Anyway, sitting right in front of the cameras, right there. But do we get rid of them? How do we get rid of fractions properly, class? Thank you, Abby, and I heard a little echo from Kendall. Let's see if everybody can answer this. Class, how do we get rid of fractions?
Multiply everything by the LCD.
There we go. Even if it's not a fraction, it gets multiplied by the LCD. You had numbers 4, 8, 9, 12, 14, and 17 on that handout to do for homework. Bueno. C. Ya. Good. I'm running out of ways to say good. Excellent. Fantastic. Yup. All right. Genesis' turn. Get all choked up thinking about it, though, Genesis. She just sits there and quietly prays a curse on me or something. You should not speak until he is nice to me again. We love you, Genesis. Is that better? Can I talk again? His name is John. Do something to be able to talk. Right. From the Bible, remember Zacharias? The angel struck him dumb. He couldn't talk till he wrote his name is John, and then he could talk again.
Okay.
Anyway, you go back to sleep back there. All right, number 4. What is the least common denominator, Kendall?
I got 36.
36, right, is one of the numbers that's actually in there. That's okay. You can certainly use one of the provided numbers. You're going to multiply everything by 36, and the point is that the 36 we multiply is going to cancel with the denominator 4. It's going to cancel with the denominator 12. It's going to cancel with the denominator 36, denominator 9, denominator 2. All of them cancel with the 36. So here the 4 and 36 class are going to cancel to give me a 9. And then I'm going to multiply the 9 times the 3D that was already here to end up with 27D. Michael, I'm going to multiply the 36, cancel rather the 36 with a 12 to get a 3 times the 70 or negative 70 that was already there.
Negative 21D.
Obviously, when I multiply 36, they're going to cancel. I'm just going to be left with the 11D after the equal sign. The 9 is going to cancel with a 36 to get Genesis a 36 and 9 cancel, give me a 4 times the 8D I already had. That's a lot of D's. And then we had a random positive 3 halves. Of course, the 2 and the 36 cancel to give me what, Maddie? 18 times the 3 ends up giving me a 54. Again, a lot of D's that have to be combined. We'll combine these D's to get Audrey 6D, and then we'll combine these to get
D.
There we go, plus the 54. The little d here, Abby, is the,
Negative 21.
we'll bring that over as a positive to end up with.
Positive 27.
And again, my advice would be, especially on a quiz or test, take the moment to write the positive 21d so you get that correct. I've seen way too many mistakes to encourage otherwise. Again, if you just show that on a quiz or test, maybe not even on the homework or classwork because we're lazy, but on a quiz or test, show that moving it over as a positive so we don't accidentally make a mental mistake. And then we divide away the 27, Brandon, and we get 2. How many had 2 for number 4? 2 for number 4, excellent. Number 8, what's the LCD in this problem, Maddie? 12, 4, 3, 6, I would use 12. How many used 12? And it would multiply by something different. What did you use? 24 works as well. You'll just get twice as big of everything out there. So if you multiply the 12, let's keep that number in mind. When I multiply 12 by the first fraction on number 8, Abby, I'm going to cancel the 12 and the 4 to get a 3. But I have to distribute the 3 to get
9y plus 12.
On the next fraction, if we had used a 12, Audrey, the 12 and 3 would have canceled to get a
4.
which I would distribute to get
4y plus 12.
on the next fraction, Michael, the 12 and 6 would have canceled to get me a 2. But it's a negative 2, right? Because of that minus in front of the fraction. So when we distribute a negative 2, I get
Negative 8y plus 4y.
well, just negative 8 positive 4y. No y there on the 8, though that could have potentially messed you up there. And then, of course, the 12 times the 5 at the end, class?
60.
60. Yeah, don't forget to multiply the 12 by the 5. How many got this? Or I guess, Audrey, if all of your numbers were doubled, you'd still be good. But how many took care of clearing the fractions correctly? You just said a y that didn't. Okay, but you had it correct on the paper.
Why,
It's okay. You're human, that's why. Questions getting to this step. Does anyone need to see it worked? I talked it through. Do we need to see it shown? All right, at this point, let's do a lot of combining. 9y, 4y, another 4y. They all combine to give me what, Kendall?
17y.
17y. Here, the 12 and negative 12 Genesis can cancel. So the only number that's left is, which I might as well go and just move over right now to get, when I move it over as a positive. Divide both sides by 17, and yes, it works out evenly. We end up, class, with y equals 4 is our answer. How many had 4 for number 8? Okay, fewer of you this time. Right here, how many had a negative 4y? Watch out for that negative, right? Because that'll get you, and you end up with what, a 9y equals 68, and it doesn't work out evenly. Watch out for negatives in front of fraction bars. So a lot of times, let me go and write this part of it. What I'll do if I'm working it for myself, especially in Algebra 1 where I tend to show more steps, I'll mark those negatives. Anytime I see a subtraction, I'll put an arrow to it. Right even before I start the problem, I don't want to miss a negative because they will mess you up if you're not careful. Questions number 8. Number 9, what's the LCD? Brandon.
28.
Number 9?
Water.
What's the least common denominator that we're going to multiply by everything?
Oh, where am I? Oh. 10.
Number 9.
10.
No, number 9. I'm just picking on you. 10 is the LCD. We're on number 9, but 10 is the LCD. And multiply everything by 10. And on the first fraction, class, 10 and denominator 5 cancel to give me a 2, which I must distribute, Brandon, to get.
10 over minus 12.
By the way, before I did any of that, I noticed there were no negatives to have to worry about. I like that. That makes me smile. Okay, and then I frown again. All right, on the next fraction, the 10 and 10 cancel cleanly, so I'm just left with what, Abby?
4y plus 7.
And my equal sign. The 10 and 2 are going to cancel, Maddie, to get a times the 1, of course, is still just. On the next fraction, Audrey, the 10 and 5 cancel to give me a 2, which I need to distribute to get.
6y minus 8.
How many got this point on number 9? Any questions so far? All right, at this point, Genesis, let's combine. I've got a 10R and a 4R.
14r.
Kendall, I've got a 12, or negative 12 and a 7.
Negative 5.
And over here, I've got a 5 and a negative 8, Michael.
You get 3. Negative 3.
Negative 3. The little r here, Kendall, is the, which I'll bring over as a, to get
8r.
8r. And we'll send the negative 5 over here as a,
Positive.
to get
2.
2. And so r is going to equal, be careful, class, 1/4. Good, not 4. We're not dividing 2, we're dividing 8. And again, on quiz or test, if you show that step, not as likely to mess it up. How many got the 1/4 for number 9? It sure is nice when there's no negatives to have to worry about distributing, right? Questions on number 9. Number 12, I see something I hate, but they're not fractions. They're fractions in disguise, if you will, and those are decimals. What is the key to eliminating decimals? Genesis? Before we get to that.
Move the decimal, or move the decimals. Well, is like look at the biggest one?
Good. Look for the decimal that has the most decimal places. I like to call it the ugliest decimal because I hate decimals, right? But if we were being kind, we might say the biggest decimal, but I'm not kind. I say ugliest decimal. Now, they actually already did this for you. Notice they already had the 0.70 L. Now, I will say it's just evil putting L's because they look like ones if you're not careful. I'm going to write them cursive so they don't look like any number that I've ever seen. But they already had the 0.70 and the 9.20. I won't do that for you. If I give you one, it'll just say 0.7. And you have to move it the second place, which would get you a 70. When I move it 2 places everywhere, what does the equation become, Genesis? When we boink boink everywhere. Or boink boink.
70 plus 25 equals positive 920.
Positive what?
20.
920?
Yes. Negative 2L.
At this point, we can combine some like terms. Audrey on the right-hand side, plus the 920. Then Abby.
Move the 6 over is negative 6. And then that equals 64 now. And then move the 24 as a negative 24. And you get 896.
And we love our calculator right about now. And we try dividing by 64 and see if it comes out evenly.
14.
Ah, very nice. And 14. All right, so how many at L equals 14 on number 12? Questions on 12. Number 14, how many times are we going to have to boink for this particular problem, Michael?
2.
2, because the ugliest decimal has 2 places. So on number 14, we go boink boink, and we get
18.
X.
Yeah.
And we go boink boink again, and we get...
You get negative 2,840. Then you get negative 6x equals 35. Negative 20x. Negative 955.
Excellent job. How many got the same thing when you clear the decimals out on number 14? All right, at this point, Brandon, we need to combine like terms on the left.
12x.
Minus the 2,840, which makes you thankful for a calculator. We also have a couple terms we can combine on the right side. Brandon, stand with you.
Negative 20x minus 920.
Well, the little x is the...
Negative 20x.
bring that over as a... to get...
32x, and then you can put a negative...
big number over as a positive to get...
1,920.
Yep, all right, and then we divide both sides by 32, and we hope it comes out evenly. Surely it does.
X equals 60.
60? Yeah, it is. How about that? Okay. All right, didn't expect something quite that even. That's great. How many got x equals 60 on number 14? All right, questions, Abby, Audrey.
I got 84 and 111.
Oh my.
I got 1,070.
All right, questions? Did you get to this point by any chance?
I had negative 60x.
Yeah.
Where?
Oh, right here. The 0.06x or the net when you went boink boink. You added an extra 0 at the end when the first 0 was already there. Okay, so Abby found her mistake. Audrey, any clue what happened? What did you say your answer was?
1,270.
Did you have a 32x or an 8x in your next to last line?
I had 14.
You had a 14.
I don't know.
I wonder if your 18 just disappeared, and so you did the negative 20 and brought it over here with a negative 6 to get a 14x. Did you sure you had 18x written down at the beginning, or did you maybe just 18 and forgot the x?
I had 18.
Forgot the x part?
I guess so.
I don't know. Anyway, maybe just forgot to combine it. All right, yeah, that would change some things. And then over here, did you have a 1920 or did you have like a 3760?
I have 1920.
Yeah, the 1920 is 14x equals 19. And what was your answer?
1,307.
And you subtracted the 14 maybe instead of dividing the 4. Anyway, you see what we should have did. Okay, when did you do this?
Friday.
During the football game? Is she screaming at the TV as the Patriots are losing to the Cowboys at the very end of the game and trying to do her homework at the same time? It's just not working well. Hey, I was not screaming at the TV this week. Well, I was a little miffed with the Gators and how badly they played against LSU. I was just like, just don't throw a shoe. Just don't throw a shoe. They just threw 4 interceptions instead. All right, anyway. We won't talk about that, will we, Kendall? No, we won't. All right, number 17. And here we have polynomial denominators. And Abby, I said with polynomial denominators, you got to do one of two things with them. Or factor or group them. Ideally factor, but if you can't factor, then group. As we look at these denominators on number 17, yeah. We got a 6r minus 7, and we've got a 9r plus 6. Can I do anything with that, Abby?
Yes.
What?
You can divide by 3 to get 3r positive 2.
I get a 3 times 3r plus 2. And then we've got a 5 times r positive 1, which didn't actually need to be in factored form, but if they're going to do it for us, I guess, whatever. Because all I really care about are the denominators being factored or grouped. And Maddie? And then equals 1/12. Really can't do much factoring on a 12 because it's not a polynomial. So we need to figure out what is the least common denominator. Well, as far as your numbers go, I've got a 3, I've got a 4, I've got a 12. What one number represents 3, 4, and 12 all at once? Genesis?
3r plus 2.
Well, just to focus on the numbers for now. I've got a 12, I've got a 4, I've got a 3. 12. And here I've got a 3r plus 2, and then I've got another 3r plus 2, but no fraction has more than 1, so my LCD only needs one of them. 1, 3r plus 2. So 12, 3r plus 2 is the LCD. How many factored and got this for your LCD? All right, excellent. At this point, we're going to multiply everything. There's 3 things, right? 3 terms. Everything gets multiplied by 12, 3r plus 2. Right here, we are able to cancel, obviously, the 3r plus 2 and the 3. So all that's left now, class, is a 4. Here, I'm able to cancel the 3r plus 2 and the 4, so all I'm left with is a 3. But it's a negative 3. And then over here, obviously, the 12 will cancel, but I still have, class, the... All right, thank you, Brandon, for answering so well just now. Hopefully the rest of you got this as well. So I need to distribute the 4 to get what, Michael?
You need to distribute the 4 to get... I did my thing wrong, but
what should you have did?
Distribute 4 to get. Hold on. 24 r. Yeah, that's correct.
It is correct.
I it took longer.
All right. How about when we distribute the negative 3? Now I mentioned before, if you've got multiple monomials, get them all together first. So let's get all this together to just get
negative 15.
And let's really just distribute a negative 15 to get
negative 15 r minus 15.
Good. And then of course 1 times 3r plus 2.
That's like 3r plus 2.
It isn't just like 3r plus 2, it even is 3r plus 2. And then we need to do what here, Kendall?
Combine that.
And we combine our r's to get
9r.
9r. And we combine the negative 28 and the negative 15 to get negative 43. All equal to 3r plus 2. And we're going to get rid of the little r. And what do we get there, Audrey? 6r. And of course, we'll bring the 42 over as a or 43 over as a positive 43. And that'll get us, class, 45. And is that going to divide evenly by 6? No. What do we get for r? Anybody?
I got 7.
You already worked it. That's on paper, isn't it? Or did you screw it up? You screwed it up. Okay.
Is it 7.5?
7.5 or 7.5 or 15 halves. 7.5, 7.5, 15 halves. Any of those would work. We just wouldn't want to leave 45/6 because we could divide a 3 at a top and bottom if we had that. Did anyone have one of those answers? Good, Michael.
I get a sticker.
No, but you don't have to feel the shame and despair and humiliation of getting it wrong. For the rest of you who do, questions. Was it the negative 15? It was for you, not for you. We got the negative this time, okay? Questions, comments? You in there, Genesis? Hi, Genesis. Head offhand. Looks slightly more awake. All right, questions on this. Let's take a look at numero 21. Number 21. At your seats. Copy it down, but don't copy it necessarily as written. Factor or group as you copy it. Don't copy down number 21, but factor or group as you do so. All right, check your initial step. How many good to go? Group, factor, and I put it over 1. We all good? Uh-oh, I'm seeing erasing. Questions? Hey, don't try to factor the numerators. We don't care about numerators, only denominators. Okay, so what's the LCD here, class? X plus 1, x minus 1. And everything gets multiplied by that. All right, so if I multiply x plus 1, x minus 1, here, obviously, class, I'm going to cancel away the x plus 1, but I still have the x minus 1. What am I going to have to do with the x minus 1 and the x cubed plus 2? Foil. But I'm not going to be able to combine the outer inner because they're not similar. So I'm really just double distributing. When we multiply the first class, outer. 2x. Yeah, 2 times x is 2x. Inner. Negative x cubed, last. Negative 2. All right, come on, people. We can do this. All right, here, I have an x negative 1. I'm going to cancel, obviously, with the x negative 1, but I'm still left with another x positive 1. Now, this is harder because of the negative. I have to double distribute and change the signs. Let's take it in 2 steps. Distribute first, but outer. X cubed, but negative x cubed. Inner. Negative 2x becomes positive 2x. Last. Negative 2 becomes positive 2. Ah, big sigh of relief, because everything cancels, so I'm just left with a 10. Nothing to multiply by the 10. And then nothing cancels. So I've got to have the x plus 1 x minus 1 multiplied by the negative 2x, but we can multiply this part in our heads. Square the first square, the last, put a minus sign. X squared negative 1. Thank you, Maddie. I heard that. We talk in physics about barely audible, just noticeable difference. 0 decibels. There we go. All right. And then we're going to distribute, Maddie. Let's see if we can get a little bit higher than 0 decibels when we distribute negative 2x to the x squared negative 1. Perfect, and I could hear it in everything. Questions on that initial step? Feet down, Genesis. Questions. Again, it's ghastly, but we are in Algebra 2 now, so we're capable of handling this. Oh boy. Let's combine. I've got an x to the 4th and a negative x to the 4th. Thoughts, class? Cancel. When we combine negative x cubed and negative x cubed, class, we get negative 2x cubed. Thoughts?
Erase it with the other 2x.
There's a negative 2x cubed on the other side. So these do not cancel each other, but collectively, they cancel this. I've got a positive 2x and a positive 2x.
2x.
4x, or we could cancel one of these with that one, and so I'm only left with 2x. I've got a negative 2 and a positive 2. 0. They cancel because they're inverses. So just left with 2x equals 10, so what's x? 5. And there's my answer. Again, the initial step of multiplying by the LCD, yeah, we had some double distribution. We had double distribution with negative. We had to distribute a negative. It worked out okay. Questions? Just be careful in all that algebra we've been going over throughout the year. Look down at number 26 now. Number 26. This is the sort of thing you dream of doing when you're little. Just kidding. All right, we've got a 1/2 x. And I'm going to distribute the negative 2, put that over 1 times the 4x over 5 class. That's going to give me what?
Negative 8x over 5.
Negative 8x over 5. And then the negative 2 times negative 3 class? Positive 6. Then, of course, I've got a 4. And I've got to distribute a negative 3 halves by x halves plus 1. What do we get there, Genesis? Negative 3 halves times x halves. Negative 3x over 4, and of course negative 3 halves times 1. I'm going to put these over 1. I'm also going to rewrite this half x as x over 2. Just make things a little easier. Questions on the initial step of clearing those parentheses out. And now it's pretty straightforward. What's my LCD here, class? 20. At your seats, finish. Check your work. How many had x equals 10 for your answer, first of all? All right, those who did not, were we on the right track? See where you left off. Are you with me here? Questions. Checking your work. Are you on track? Are there any questions? Write this down in your notes if you would. X negative 3 over x positive 4 is equal to 2/3. Technically, we could multiply everything by the LCD, but there's a shortcut here when you have just a single fraction equal to a single fraction. First of all, who remembers from years gone by what we call this thing of one fraction equal to one fraction? You could argue that, I guess. A proportion. Write that in your notes. We call this a proportion. How many remember that now that we said it? Proportion. And we call these two terms here the means of the proportion. And then we call these two terms here the extremes of the proportion. The means, if we counted 1, 2, 3, 4, the means are the second and third terms. The extremes are the first and fourth terms. And we know this, that in any proportion, the product of the means equals the product of the extremes. If you'll write that in your notes as well. The product of the means equals the product of the extremes. Again, that should sound very familiar to you from years gone by. Those in geometry, it might sound more familiar since we did a lot more with proportions than those who were in Algebra 1 last year. In any proportion, the product of the means equals the product of the extremes. What would be the product of the means here if I were to cross multiply x plus 4 by 2? Class? 2x plus 8. And we said that the product of the means equals the product of the extremes. What do we get if we multiply the extremes together, Genesis? 3x negative 9. And then we'll bring the 2x over, send the 9 over. What do we end up with, anyone?
X equals 1.
Ooh, careful.
X equals 17.
X equals 17 is our answer. Write this one down. 2x plus 3, or 5x plus 3 over 2x minus 3 is equal to 5x plus 7 over 2x. 5x plus 3 over 2x minus 3 equals 5x plus 7 over 2x. Once again, we have a single fraction equal to a single fraction. So rather than multiply everything by the LCD, we could simply, since it's a proportion, cross multiply. So does that sound at least familiar to you? Right? And that's what we call it, because the product of the means, that's what we call a cross product or a cross multiplication, equals the product of the extremes. So we're making a big X, if you will, in our multiplication, hence cross multiply. When I multiply the means, I'm multiplying a binomial by another binomial. In other words, class, we're going to have to do what? FOIL. What do we get when we FOIL here, Abby?
10x squared. That's positive 14 and then negative 15. So negative x, negative 21.
Good. First is 10x squared, outer is 14, inner is negative 15. That combines for negative 1x, and then last is negative 21. When I multiply the extremes together, since the product of the means equals the product of the extremes, I don't have to FOIL. All I've got to do, Michael, is
10x multiply.
Distribute is what we call it, and we get
10x squared plus 6x.
10x squared, positive 6x. And then from here, we solve, Brandon. Yeah, let's make life easy here.
Move the negative x over to positive negative 3 equals x. 7x, and then you divide the 7 away to negative 3 equals x.
There we go, x is negative 3. Technically, you're doing the same thing as you would if you multiplied by the LCD, but it's a faster way of thinking of things. It's just cross-multiplying when you have two equal fractions, when you have a proportion. Questions on solving proportions. Turn your books to page 110. Page 110. And do numbers 12 and 14. Page 110, do numbers 12 and 14. You have a couple of proportions there in 12 and 14. I need you to cross multiply and solve. Audrey's got them. Brandon's got them. Michael's good. Maddie's got them. All right, let's take a look at our answers here very quickly. Pencils down, even if you're not finished. Number 12, the product of the means, 14x plus 56. The product of the extremes, 8x plus 14. Get the x by itself, should have had x equals negative 7. How many had negative 7 on number 12? Number 14, cross multiply the means to get negative 7a positive 7. Cross multiply the extremes to get negative 8a positive 20. Should have ended up getting a equals 13. How many had a equals 13? All right, questions on those. Homework for this evening is to do the handout, numbers 18, 23, and 24. On the handout, numbers 18, 23, and 24, I would get rid of parentheses, by the way, before trying to multiply everything by the LCD. I'd get rid of the parentheses first, then multiply everything by the LCD. And then on page 110, numbers 11 and 13. Page 110, numbers 11 and 13. We'll take a look at all of this in our next lesson as we also continue looking at more word problems. And when the bell rings, you'll be dismissed. Have a wonderful rest of your day.